Okay, so we are going to talk about completing the square today. So basically, last lesson was about solving with the square root, right? So the square root property. So sometimes we don't have that perfect square and we can't factor. So what do? Well, we need to complete the square, or we could complete the square. So in this lesson, I want you to be able to identify that perfect square trinomial and factor it, and then also create a perfect square trinomial if you don't have one. Okay, and then let's go to example 1. Okay, so first off, because we have the x term, we're going to just see if we have a perfect square trinomial already. So this one was 2x squared. Yep, that's good so far. And this is 5. So we do have our perfect squares. Is the middle twice the product of the 2x times 5? Yeah, it is. So we're going to be able to factor that into 2x and 5, and we're going to be able to use the sign of the middle. So perfect. So now we can use our square root property. So take the square root of both sides, and we get 2x minus 5 is equal to plus or minus 4. So that means that 2x minus 5 is equal to 4, or 2x minus 5 could have been negative 4, because both of those would have squared to make a 16. That makes sense. So let's go ahead and solve this. Adding the 5, 2x is equal to 9, divide by 2, and we're going to have our first value, 9 halves. Let's go on this one, add 5, 2x is equal to 1, divide by 2, and our next one is 1 half. So there's our two solutions. So all we had to do here was identify that perfect square. Okay, let's do this one now. This is just a perfect square of x. And this is just a perfect square of 4. So is the middle 2 times x times 4? And heck yeah, it is. So we have our perfect square trinomial, which is made with an x and a 4, and our sign of the middle is negative. So we now will take the square root of both sides, plus or minus, and then x minus 4 is equal to plus or minus radical 10. Now, because I can't not simplify radical 10, and I'm not going to have anything in common, I can actually just add 4 right here, and I can write my solution as 4 plus or minus square root of 10. Now, if you wanted to write 4 plus radical 10 and 4 minus radical 10, you may do that too. All right. So, well, what happens if we don't have a perfect square? Well, we need to learn how to make one. So let's think about what we had here. We need something squared, let's say a, and we need something squared here, b, and in the middle I need 2a times b. Okay, well, so I need 2 of the product, right? Well, we already know that it has x, right? Because we have the x. So we do know that it does have the one from here. But we really need to have that the middle is 2 times b, right? So if the middle is going to be 2 times b, then in order to get b, right, I can take the 14 and divide it by 2. That will give me 7. Well, this c value has to be b squared. So we will then square it to get our c value. So c would have to be 49. And what I want you to see is that that would make this x squared plus 14x plus 49. So basically what I did was I completed a square. This actual square would be x plus 7 squared. So I made a perfect square. So we're trying to find out what c value would make a perfect square. The c value would be 7 squared, which is 49, right? So the c value would have been 49. Okay, so let's think again, how did we do this? Well, first of all, to complete the square, we have to have a leading coefficient of 1, because that makes it so we're only focusing on what would happen in the end. So we would take the negative 22, which has to be 2 of the product, and we get negative 11, and then we square it. And that would be 121. So that means C would be 121, which means we would rewrite this as x squared minus 22x plus 121. And then if we wanted to, we could then make it a perfect square with x and 11 using that middle term because we just created that perfect square. Okay, so how do we then use this in an equation? Oh, this is super messy. This is supposed to be b over 2 squared. And that's what we've been doing, is adding b over 2 to squared to make our perfect square. So what is the first step? The first step is to make sure that 1 is the coefficient of the quadratic term. If we don't have 1, we're going to divide all terms by a. Divide all terms by a if a is not 1. That's super important, okay? Then we're going to isolate that quadratic and linear term. Okay, so when I'm talking about the quadratic and linear term, if I'm looking at a polynomial, this is the quadratic term, this is the linear term. Quadratic, linear. So I want to isolate those, get those alone on one side, okay? Then I'm going to go ahead and do what I did above, which is make that perfect square. So isolate them, then I'm going to make the perfect square, and then I'm just going to basically solve from there. So let's check this out. Okay, first of all, our leading coefficient, or the value in front of x squared, is 1, so we're good to go. I'm going to now check to see if this is a perfect square trinomial. This is not a perfect square trinomial because 18 isn't even a perfect square. So what we're going to do is isolate the x squared and the 18x, the quadratic and the linear term, and then I'm going to add something to make that a perfect square. But if I add it to the left, I must add it to the right. Okay, so going back up here, we remember that it's b over 2 squared. So b is this value. So I need to take half of this value and square it, because remember, we had to have 2 of them in the middle. So this is going to be 9 squared, which is 81. So 81 would be like our c value up here, except for now we have it on both sides. So let's make our perfect square. It's made with x plus 9. That's what this is, x plus 9 squared. And then we're going to have 100 on that side. And now we're just going to solve it like we did when we already had a perfect square. And so we have x plus 9 is equal to plus or minus 10. And so this is x plus 9 is equal to 10. X plus 9 is equal to negative 10. And we get x equals 1. And x equals negative 19. So we did get our 2 values, which are 1 and negative 19. All right, cool. Let's look at the next one. Well, when I look at this to see if it's a perfect square, obviously that too is not a perfect square. So immediately when I see that it's not a perfect square trinomial, I'm going to have to get rid of that a term, which means I need that a term to be 1. Well, we get 1 by dividing it by itself. So whatever we do to one thing, we have to do to all. Okay? So now we have x squared plus 8x minus 5 is equal to 6. Well, now we fixed the first term, but now when we look at that last term right here, that's not a perfect square. Definitely not a perfect square, right? So what we're going to do is we're going to isolate the quadratic and the linear term by adding 5. And then we're going to set ourselves up to complete the square, or make a perfect square. But whatever we add to one side, we must add to the other. All right, so we're going to take our b over 2 and square it. So that's 8 over 2 squared. So this is 4 squared, or 16. So now we're going to have x. Let's make this a different color. So this one right here, we turned into x plus 4 squared. And so this is equal to 27. So now what we're going to do is we're going to take a square root of both sides, plus or minus, and we're going to get x plus 4 is equal to plus or minus. Now this is 3 times 3 times 3. So this would be 3 comes out and a 3 stays in. So let's see, if I subtract 4 from both sides, because the reason I can do this and not make two terms is because they don't have anything in common. So this is just going to be negative 4 plus or minus 3 radical 3. All right, so basically if you wanted to write this out, it would be negative 4 plus 3 radical 3 and negative 4 minus 3 radical 3. And now we're going to do one more. And sorry if you hear any background noise right now, but so looking at this first one, we see that this is not a perfect square. So we're not going to have a perfect square trinomial because number one, we don't even have a trinomial on that side. But immediately then we're going to divide everything by that leading coefficient. So we'll end up to have x squared minus 5/3 x. Now we know we're going to be setting up for a perfect square. So we're going to just go ahead and set that up. But whatever we add to one side, we have to add to the other. Now here, when we do our b over 2, now we have a fraction that we're dividing by 2. Whenever we take a fraction and divide it by 2, it's really just multiplying the denominator by 2. So this is negative 5 over 6 squared. Well, that would just be 25 over 36. Doesn't really matter that much for the left because you already made a perfect square, and that was with x, and this is minus, so minus 5 over 6, because that's the thing that you squared. See this negative 5 over 6 here? That's what you're putting down here. So we're using the same thing as we did before, but now on the left side, we have to get a common denominator. So we'd multiply that by 12, and we get 24 over 36 plus 25 over 36, which is 49 over 36. Now we're ready to take the square root of both sides. So we take the square root of both sides, and we're going to get x minus 5/6 is equal to plus or minus 7 over 6. Okay, so that definitely gives us two things. This is x minus 5/6 is equal to 7/6, and this is x minus 5/6 is equal to negative 7/6. So those are our two statements, and we'll add 5/6 to both sides, which is nice because they already have a common denominator. And so we'll get 12/6, which is just 2, and then add 5/6 to this side, and we're going to get x is equal to negative 2/6, which is just negative 1/3. So this is going to be 2 and negative 1/3. All right, cool. So this is just an example. This is probably the example that you're going to want to focus on the most because it has fractions, and most of you don't like fractions. And the key here is to remember when you divide a fraction by 2, it's really just multiplying the denominator by 2. Okay, have a great day, you guys.